Hello, welcome to today's class. Let's consider yet the second example involved in first principle method of differentiation. Before I solve this problem using first principle, let's try to solve it using general method to get our answer, right? So let's say I have that question there. I have that y is equal to x squared. I'm asked to find the y over the x here. Let's perhaps use general method first before we use what we're asked to use, known as first principle. From here, I'm saying y and x. Basically, no one should tell you. You should know that we're differentiating y with respect to x. So I should have the y over the x here as being equal to, what's the power here? The power is of course 2. Said multiply by the power and then subtract 1 the power, as easy as that. The power here is 2, that becomes 2 times, here becomes x squared. We said subtract 1. I have this. If I evaluate this, or perhaps solve this, I'll have that this is 2 times, this is x to power 2 minus 1 is of course 1, right? And from indices, any value or variable raised to power 1 is that variable itself. So from here, I shall have 2 times x to the power 1 is x. Multiply 2 by x, I'll have 2x. Solving this problem by using general method, I have 2x. So if I use first principle method, I'm expected to have that same 2x. Let's do this and let's see if we're going to have the same answer, or perhaps if our answer will be comparable. All right, from here now, we said what we know before now is that we said when it comes to first principle, the key concept is that to y add change in y, and then to x add in x, as easy as that. So from here, I have y, to y add change in y is equal to, I'm seeing x squared. Please, mind you, I know that if for a new student taking this course here, we're expected to write x squared plus what? Change in x. This is wrong, please. This is wrong. We said just to x, not to x squared. We said just to x, add in x. So I'll clean this x, become just this x plus what? Change in x. Open a bracket into what? This is not square. You put a square outside this way. This is how you evaluate this problem. So to x alone, add change in x. This square should put outside this way, not x squared plus change in x. This would be a very wrong approach to this problem here. All right, let's proceed with the solvings. At this junction here, we said always take y to the what? Other side. So I have that change in y is equal to what there? X plus change in x all squared minus what? Y, because e plus y becomes what there? A negative y. All right, proceeding from here, what I have here, this becomes what? So at this junction, I will now say, but this y we took from the question was what? X squared. Y was x squared from the question, right? So as easy as that, I'll just substitute the value of y as being x here. So I'll have change in y is equal to x plus change in x all squared minus, what's your y here? Y is x squared, as easy as this. So I have this one here. All right, I will expand. This is x plus x squared. If I have x squared, it simply means x times x. Similarly, if I have x plus x squared, it simply means x plus change in x is multiplying itself twice, as in this case. If I'm to expand this one using binomial theorem or perhaps Pascal's triangle, I should have that change in y is equal to x squared plus 2x change in x plus change in x squared. If I'm to use Pascal's triangle or the concept of binomial expansion, I'll have this. It becomes what? Minus x squared. For the sake of teaching, I'll try to explain how I got to this expression. So let's say I have x plus change in x squared. We said this thing, it means that this thing is multiply itself twice, as I expressed in this case. So I should be having x plus change in x into x plus change in x twice, right? So how do you expand these two brackets? It's quite easy. We said the task is that take out the first term in the first bracket, that is x, multiply by everything in the other bracket, x plus change in x. I'm done with this. Take out the second term in the first bracket, that's plus change in x, multiply by everything in the other bracket, x plus change in x. I said pick out the first term in the first bracket, this is here, multiply by everything in the other bracket. So I have this. Next up, pick out the second term in the first bracket, that's plus change in x, multiply by everything in the other bracket. So I have this. For me, what's the next task from here? If I expand this, x times x, of course, x squared plus x times change in x. Look up. If I have x times change in x, neutrally, you tell me this answer becomes change in x squared because x times x is x squared. This is wrong, please. This is wrong. We assume that x and change in x are two different things, right? They're not the same. So here's the thing. X times change in x becomes what? The x change in x, not what? Change in x squared, please. Correct, I have this. Plus x change in x times x is what? X change in x. Next up, plus change in x times change in x, I have change in x squared. From here, I can see like terms. Of course, x change in x, x change in x. So I'll combine it together. So I'll have what? X squared plus, this is 2 of it, 2x change in x plus what? Change in x squared. So on evaluating this problem here, I have this. So this answer is what I have here, as you can see, right? So I actually use a shortcut. So if you're interested in learning the shortcut, simply check or perhaps check the description of this video. I'll drop a link or a class to how to solve problem using binomial theorem or perhaps Pascal's triangle. So watch that video so that you can understand how I possibly use the shortcut to solve this problem here. Proceeding from here now, observe that after expanding this stuff, I brought out minus an x squared. This minus x squared will cancel out what? Plus x squared. That's 0. So I should be having what? Change in y to be equal to, this is 2x change in x, right? Plus change in x squared as being the left value here. Check your previous example that we did, right, in our previous video. When we cancel out stuffs, right, this way, what are our next task? We divide through by change in x. So after cancelling out this way, you divide through by what? Change in x. So divide by change in x. So what do I get here? Divide both sides per se, right? So change in y over change in x equal to, pick the term individually and divide them by change in x. So I will not say 2x change in x, right? Change in x plus change in x squared over change in x. This is wrong. This is wrong. Pick them individually. So I shall have this one alone change in x and this alone change in x. Mind you, I have a square here. What comes to mind here? This man will cancel this. This one will cancel this. But I'll be left with one of it up here. So therefore, I'll be having change in y over change in x as being equal to, I'm left with what? 2x here plus, I'm having what? Change in x here. Observe the difference between the first example and second example. For the first example, after dividing through by change in x, I have my answer straight as 1. But here, after dividing by change in x, I'm still having a change in x left. So here's the condition. If you divide through by change in x in first principle, and you are still left with change in x, Just take the limit of changing x to be 0. Take the limit of changing x to be 0. In a layman word, it means anywhere changing x, put 0. That's the concept. From here, change in y over change in x will be equal to 2x plus, we say assume this to be what? 0 plus 0. If 2 multiply add up with 0, I'll have 2x. So therefore the change in y over change in x, which is similar as the y over the x, will be equal to what? 2x. Of course, observe when I use first principle, I had 2x. Similarly, when I use the other method, I still have 2x. This is how you evaluate problem using first principle method. Next class, I will introduce the general formula for first principle in the next class. So do well to like this video, leave a comment, share to your friends and classmates so they can learn too. Also do well to subscribe to my channel. See you in the next class and welcome to Excellent Link Academy.